Welcome to week 3 of Math OER, level C math, and we are starting a new topic. We did all of shape shifting with the first 2 weeks. Hopefully that was a good pace, and you got to either have review if you knew that, or have things explained a new way, and your homework and everything. Let me review very quick what we've done, and feel free to holler out and say, oh yes, I want some more example problems of those, or looking at the homework. But I am assuming that since I just, if anyone wanted more review and no one said anything, that we're actually okay. So correct me if I'm wrong. We are not in a rush. We can do more review as needed. I'm also taking attendance as people log in, so you don't need to say hi in chat or anything. I can see that you're here. Okay, so clicking over on the Lego guy for shape shifting, we started by talking about rounding and decimal accuracy, how division made us have fake decimal accuracy, and that was often why we rounded. Estimating that if we rounded before the final answer, it would change the answer, but sometimes that was useful because we could get a good enough answer. We could especially see if the answer we get with a calculator seemed reasonable or not, to know if we hit the wrong calculator button, because that happens. Then we talked about fraction format, how to understand division better, because fractions are sort of like division that's waiting to happen. We talked about the tricks to know if a number was divisible by this factor or not. We talked about how to change factors to have whatever denominator we want. We changed fractions to decimals, and we talked about ratios and rates, which were not part over whole, but were written like fractions, and later we'll do fraction math with them. Then with percents, we talked about what percents were, how to do decimal point scoots for times 100 divided by 100, things like that. The 4 things we could replace percent with, and then how to move back and forth between percents, decimals, and fractions using whichever of the 4 replacements for the percent sign was the easiest in that situation. Then lastly, we talked about measurement units, where we get their measurements unit from historically, how to convert between measurement units if we know the conversion rate, like there's 12 inches in a foot. There was a shortcut for the SI, the metric system prefixes, where you would scoot over on a row of letters of the prefixes and just scoot the decimal the same amount, so you didn't actually have to do more work. And then we talked briefly about what an exponent was and what a square root is. So that's something you can do to one number also. Oh, I had planned on doing a test today, and I totally forgot about it, that we were all going to work together as if we were taking this test. Is that something you still want to do? I can make up a PDF and send it out quick, but I'm guessing that if some of you are on phones, that's not going to work well.
I'm fine with anything.
If no one's too disappointed, why don't we do this next class, and we'll just keep going today. I am sorry for the change of plans. Let me put something in chat, a reminder for me. Okay, there's my note to myself. So on Thursday, I will send out a PDF of these so we all have the same one, and we can see how much we're really done with this and how much we need review. But if you were like me and got distracted by all the sunshine over the weekend, then you probably haven't studied for this anyway. Okay, we're going to go on then and talk about mad science, putting things together, squishing things together with arithmetic, starting with everyone's favorite, fraction arithmetic. But again, before I do that, anyone need any of these topics reviewed?
I do.
Which one?
It's under the percent format.
Okay.
And I want to say it was number 10.
The 10 exercises.
Yeah, it was, number 10.
Okay, I put a link in because I hadn't talked about this enough.
Yeah, I got your email. I just haven't had time to look over it yet.
Okay, so there were 3 different things that were good to memorize. By the way, somebody asked for some help since I saw you Thursday on the 10 exercises for measurement. So I'm leaving that there just so it will be in our record at the end of the day. So there were 3 things that were just good to memorize. I didn't spend enough time on it. This is something that the Math 20 curriculum cares about more than Level C math, but we'll do this too. So if I just take out my calculator and do what is 1/3, one divided by 3, then I get 3's repeating. So I will write that down. 1/3 is 0.333 going on forever. And the official way to write that is with a bar over the 3. That shows it goes on forever. I'll talk about that a little more in just a moment. If I do 2/3, it's going to get doubled. So 2/3, well, all the 3's turn into 6's. So it's 6's that go on forever. And you can check that on your calculator if you want. And then 1/6, if I look at that one, it's going to be half of a third, which isn't quite obvious what to do. But it's 0.1 and then lots of 6's. This 7 is really more 6's. It's just rounding up on the calculator when it gets to the edge of the screen. So before I write this correctly, what if I wrote it incorrectly and just put some dots at the end here? Now I'm confused. Is this thing a 0.1 with 6's forever? Or is this thing wiggling back and forth, 1, 6, 1, 6, 1, 6, 1, 6? See where it's ambiguous with my dot, dot, dot? So the reason we have the bar over the top is that if it was one of these as opposed to the other, I could put the bar over both to say it's 1, 6, 1, 6, 1, 6. They both repeat. Or I could put the bar just over the 6 to say that there's only one time the 1 appears, and then it's just the 6 repeats. So that's why people use the bars instead of the dot, dot, dot. But for the only ones that repeat that we care about, then it's just these 3, and the dots are not terribly ambiguous. So we can be lazy. Okay. So why would we care about memorizing these? Because it's hard to go the other direction. If you give me a decimal and say turn it into a fraction, our process for doing that was to say its formal name. Instead of 0.4 or 0.4, we would say formally this is 4/10. And once we say that, we can just write 4/10. And at that point, either we're done or we need to do some reducing, because fractions aren't considered good answers until we finished reducing. But that process of saying its formal name requires the fraction, requires the decimal stops. If the decimal keeps going, then this isn't a fraction. This is not a decimal with a formal name. It is not 3/10. It is not 33 hundredths. It is not 333 thousandths. Right? There is no formal name that captures every 3 because the 3's keep going. So we don't have a process for changing a repeating decimal into a fraction. So these 3 appear so often, 0.3 repeating, 0.6 repeating, and 0.16, with the 6's going on repeating, that we just need to know they're 1/3 and 2/3 and 1/2. So we want to memorize them for this direction, because this direction the calculator can do. Okay, now back to your actual problem. Oops. So use what we have memorized to write 33 1/3% as a fraction. We could take the 1/3 and change that to 0.3 repeating. And then we can take the percent why does it say fraction? I should have said percent there to be what I was just doing. Then we would scoot the decimal point twice and it would get 0.333 repeating. I don't know. I guess I was just distracting you by all the stuff I said. If I wanted to change that into a percent, into a fraction, I would just say that it's 100/3. Remember, you multiply these two and then add that one to get your new numerator. And then I have
That's what I was confused about. I wasn't sure how to do what to do with the 33.
Oh, okay. And one of the things we could replace a percent sign with is times 1/100. And then we'll get 100/300, which we can reduce to be 1/3. So I should make like a 10A and a 10B where we change it to a decimal and a fraction. Oh well, what I showed you earlier is good stuff too. Okay, so all you cared about was this part.
Yeah.
Yeah. Do you need me to review changing mixed numbers into improper fractions?
Yeah, that would be nice.
Let's do that. I'm going to start with some numbers smaller than 33 though, so. Screen a little bigger. Holler if that doesn't work for you. So I have something that looks like 2 1/3 is how many thirds? And I want something that goes in the box up here. So I'm going to show you first with pictures, because lots of people like that. And then I will show you the process that I mentioned before and how they fit together. So if I was to draw pictures of 2 1/3, then I have 2 holes. And I have another hole that has only 1/3 filled in. Two 1/3. How many thirds are there? I have to take my holes and chop them up into thirds also. And then I count them. 1, 2, 3, 4, 5, 6, 7, and I get 7 for my answer. So good so far?
Yeah.
So what did I do? This was 3 pieces, and this was 3 pieces. So together, I have 2 times my 3 pieces. So every time I have the whole number, I'm going to get 3/3. So that's why I have 2 times 3 in my process. This is my 2 times 3. Here's 1, 2, 3. Here's 1, 2, 3. I have 2 3s, I get 6. And then I add back the 1/3 that was just floating off to the side as my part of a pi. So my process is that first I multiply these two. And then I add. Let's do another one. What if I had 3 3/4? This time, let's swap it. Let's do the process first. What's my numerator going to be?
15.
Yeah, 3 times 4 is 12, 13, 14, 15. If I draw it, I should get the same thing. I have 3 holes. I have another pi that I have chopped up into quarters. I have 3/4 shaded. And then I also have all of the 3 pi's. How many quarters are there total? I have 4, 8, 12. That was the 3 times 4. And then I have the +3 from up there. Was that enough, Brandy?
Yeah, that makes sense. Thank you.
Okay, happy to help. Anything else from all of the stuff we've done in weeks 1 and 2?
I'm good.
I'll make another note in chat. Make number 10 be about the writing. Okay, on that we'll start the next thing. So I'll click on the mad scientist and mad science. So mathematicians have what they call an expression, which is when we're squishing numbers together with arithmetic. So all of these things in the middle of the page are different expressions. So we're going to deal with expressions for a while, and this will take longer than 2 weeks, perhaps. There's more stuff going on here than in the shape-shifting section. So that's okay. It will take as much time as we need. We are not in a rush. There's a little note in this paragraph that if we put a y equals in front, then technically it's not an expression anymore, it's an equation. But if all we're doing is plugging things in and having the y dump out the other side, then it's effectively the same thing. We'll talk about that another time. But for now, let's talk about what to do with fractions. And the first and easiest thing to do is to multiply and divide them. So how do we do fraction multiplication? Actually, let me grab my titles for the Jamboard before we go on. Okay. By the way, I still haven't heard about the textbook. You're supposed to be getting codes. It must be taking a while to order them or something. And sorry on behalf of the ABSE. Okay, we're going to multiply a third and a half. Have we done things like this in class yet? We've done something similar with changing fraction denominators, but I'm not sure we've done this. So we want to do 1/3 times 1/2. We're not just changing halves into sixths or something like that we did before. So I want multiplication to be like the word of. So 1/2 of 1/3 or 1/3 of 1/2. So I'm going to take my pi, cut it in half, and just say, I only care about half of it. The other half, I'm whatever, giving to Sequoia. So this piece was shaded in, but now it's gone. That's someone else's. The only thing that I have is this piece. That was my third of the cake. And then when I got to keep half of everything, I got this one piece. So I wind up with just this much cake. So it's 1/6. Let's do another one. So first of all, what amount of the overlap shading was there? It was 1 out of 6. What are the denominators counting? So what are the ones doing in this picture?
That is what you have out of 3, isn't it?
Yeah, the ones are kind of how much I have. I like how you said that. So initially, I had it says that I had 1 out of 3. The 3 is that the denominators are how many there are, and the numerators are how many I have. And the second fraction, it was now we're going this way. And I have that one out of the 2 halves. It's still true that the top is how many I have, and the bottom is how many total pieces there are. I have 1 out of 2. And I'm going to back up some because my artwork is atrocious. I think I am just making it more complicated if you weren't watching the video and trying to look at this afterwards. Okay. So denominators, how many pieces? Numerators, how many are shaded or overlap shaded? We're trying to sort of bundle things together into a group. This one that's special is part of the 1/3 bundle, and it's part of the 1/2 bundle. It's an overlap. That's what we want when we multiply. Now let's do 2/3 and 3/4. Somebody be my narrator and I will draw what you tell me to draw. So we want 2/3 times 3/4. Where should I start?
2/3.
2/3. Oh, okay. So I have now shaded, oops, 2/3. Okay, then what?
3/4.
3/4. I'll go the other direction. Oops, other direction for the fourths. That's what works. Again, pardon the low quality of my artwork. So 3 of these quarters. Maybe it would help us to label things. The 2/3 we were looking at on the top or bottom. The 3/4 we're looking at on the left or right. That makes this look crowded. I'm gonna scoot that over. Okay, so how much is overlapped? First, what size piece do I now have?
12.
12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can everyone see on the picture the 3 times 4 equals 12 happening?
Yeah.
3 here, 4 here, 12 boxes total. Okay, and then how much was overlapped? Shaded both ways.
6.
6. 1, 2, 3, 4, 5, 6 was both. Okay, and can you see in the picture the 2 times 3 is 6 happening on the top?
Yeah.
So if the pictures help you, yay. The overlap is again 6 out of 12. The denominators are still counting how many pieces we're cutting the cake into, and the numerator is how many things are shaded overlapped. So to multiply fractions, our process, we're going to use the fancy word for process, which is algorithm. Our algorithm is to treat it as 2 independent multiplication problems. Multiply across the top, multiply across the bottom. Whether or not this is counted as done and you have to reduce it is sort of a different issue. That's not really part of the fraction multiplying, that's just part of being done. So that's our definition for multiplying fraction. I'll go ahead and put it on the Jamboard. So let's try 2/3 and 7/5. What's the top going to be?
14.
14. What's the bottom going to be?
15.
15.
Can we reduce it? No, we're done. Yay. Everyone okay so far?
Yeah.
Yeah.
Okay. How about 5/7 and a 10th? 5 times 1 is 5. 7 times 10 is 70. That one I'm not done yet. I can divide by 5, top and bottom. If I had 50, that would be 10 5s. And then the other 20 is 4 more 5s, so 14. I think my mental math is okay. Okay, so far so good. The next thing we want to talk about is canceling. In this previous problem, I got this annoyingly big thing. I don't want a 70 on the page if I can avoid it. Is there some way that I could do my reducing by 5 early? And the answer is yes. I could take my 5/7. Is this too close to the bottom for anyone's screen?
Yes.
Yes, it is. Okay, I'll start a new screen. So 5/7 times 1/10. So I could do my divided by 5 top and bottom here. 5 divided by 5 turns into 1. 10 divided by 5 turns into 2. And then when I multiply, 1 times 1 is 1. 7 times 2 is 14. And I get the same answer, and there's no 70 anywhere on the page. So see how that is the same as what we just did. It is just that I'm moving my reducing over here to that part of the problem. I am reducing early, so I don't get the big numbers. Most people don't write it this way. What you normally see is little slashes, something like that. Does that look familiar?
Yeah.
So the 5, maybe you'd put a 1 there, maybe you don't. 1 times 1 is 1. 7 times 2 is 14. So it just looks a little different. On one hand, this kind of notation takes up less room. On the other hand, it's not immediately obvious if I was to go back and try and use this as a cramming for a final exam problem, what I did. It doesn't say divided by 5. But you can stare at it and figure out, oh, I divided by 5, top and bottom. Okay, let's do 3/5 times 1/12. So try that yourself. And also 6/11 times 2/3. And finally 10/15 and 6/8. When you're done, if you have a camera, hold it up to your camera so I know you're done. And if you don't, then do like a Moodle thumbs up or put something in chat or something like that so I know when to move on.
A Zoom thumbs up?
A Zoom thumbs up. Yeah. I said Moodle, I'm sorry, Zoom thumbs. I'll pause the recording.
You can go ahead. I got caught up too late, so I
Okay,
gotta figure it out.
on the top one, where did the canceling happen?
3 and 12.
3 and 12. We can divide 3 divided by 3 is 1, 12 divided by 3 is 4. Multiply across, 1 times 1 is 1, 5 times 4 is 20, and we're done. Okay, on the second one, where did we have canceling happen?
6 and 3.
6 and 3. 3 divided by 3 is 1, 6 divided by 3 is 2. Now I have two 2's. Can I take both of those and do more canceling?
I don't think so.
No, we can't. So if we remember that what we're doing is reducing early, I need something on top and something on bottom. Otherwise, I'm not reducing early. I'm trying something else. Not going to work. So as long as one number is on top and the other is on bottom, I can reduce. In this case, 11 doesn't play nice with anything. So 2 times 2 is 4, 11 times 1 is 11, and we're done. The last one, we have lots of options. So tell me where you started, but there's lots of things that can happen.
I did 10 and 8.
10 and 8. So 10 divided by 2 is 5, 8 divided by 2 is 4. We could just multiply across, get 30 over 60, and then start reducing. There's no requirement to cancel as much as you possibly can. Reducing isn't a terrible thing, but you could certainly do more reducing here. So I'll switch colors. What's another bit of reducing we can do?
The 6 and 15 with 3.
Yeah, 6 and 15. 6 divided by 3 is 2. 15 divided by 3 is 5. Again, a perfectly normal thing to do would be at this point to go 5 times 2 is 10, 4 times 5 is 20, and start reducing. There's no requirement to cancel as much as you can. But we could if we wanted, so let's keep going. I have two 5s. I can cancel out both of those. 5 divided by 5 is 1. 5 divided by 5 is 1. It's okay that they're in the same fraction. It's not like we have to have some diagonal business going. Since all we're doing is reducing early, as long as something's on top and something's on bottom, we would eventually have to reduce that. And lastly, 2 times 4. 2 divided by 2 is 1. 4 divided by 2 is 2. 1 times 1 is 1. 1 times 2 is 2. I've never seen anyone do this problem the way I just did with canceling 4 different times. It's much more natural the way everyone's brains work to do some canceling, then multiply, and then do some reducing. But you could do lots of canceling if that's what you like. As a side note, I used different kinds of slashes and different kinds of colors. And that way it was easiest when I went back to look at this. I'm studying for some future test to see what I did where. Ah, the 6 and the 15 went together. That's what the green is telling me. If all of your slashes are in pencil and the same direction and just single slashes, then it's hard to know what happens if you're canceling more than once. So not a requirement, but just a tip. Do single slashes or double slashes or this way or that way or wiggly slashes or something. If you keep them distinct, you'll be happier later. Okay, how about a fraction times a mixed number? 2/3, 1 4/8.
Would you change it to 12/8?
Yeah. So we had this excellent thing earlier. Thank you for asking for that review, Randy. So 1 times 8 is 8, plus 4 more is 12. And then I can do what I did before. I can multiply across and then reduce, or I could do some canceling. 3 and 4 becomes 1. 3 and 12 becomes 1 and 4. 2 and 8 becomes 1 and 4. My 4s are going to cancel, so it's just going to be 1. If it helps, I can say it's 1/1, which turns into 1. I'm curious, how well did I put that in? I explained it okay. Okay, enough of multiplying. Let's talk about dividing. This part here on the screen is something for you to stare at and kind of meditate about at home. Why does fraction division work? We talked about making piles of a fixed size as understanding division, problems like this that we could just talk ourselves through, ripping up papers and so on. So if you think about it and see what's happening that's numerator like or denominator like, you can actually understand why the division process works. But that's not something I can really briefly tell you. You just have to kind of ponder it for a bit. So we will skip right to the definition that to divide fractions, we flip the second one and multiply. There's a fancy word for this called reciprocal that maybe you know, but we're not going to care about. So I will keep the first one the way it is. I will change the 3/4 to 4/3. And then I'm changing the division to multiplying. So the second one is always the one you flip over. In this case, I can do a little bit of canceling and get 2/3. Questions so far?
I'm good.
Again, the important question is why this works, but that's something that isn't really a lecture topic. It's a stare at it at home topic. Okay, so we can do more of these. Let's do one with mixed numbers, just in case those are scary. As a side note, I don't care if your answers are mixed numbers or improper fractions. If you go into baking and carpentry, your boss will want mixed numbers. If you go into computer programming, your boss will want improper fractions. So I'm going to take the 1 2/3 and change that to 3 plus 2 is 5/3. And I'm going to take the 1 2/8. 1 times 8 is 8. 9 10/8. Okay so far?
Yeah.
Then I flip the second one and multiply. Five and 10. And I can also do an 8 and a 2. And I get 4/3. If you wanted to write it as 1 1/3, you could. but 4/3 is fine. Okay, so we have videos, we have textbook exercises, and then we get to adding and subtracting fractions. Any other questions on the multiplying or dividing before we move on?
I'm good.
I will work on those questions for you. Not ready yet.
The ones we just did?
No, the beginning ones.
Oh, from the old homework?
No, the ones that you did before this.
Ah, okay. Yep, practice more. You have I purposefully have more problems in the sample notes than we have time for the first round of lecture. Partly that's so if everyone has questions next class, then we can have more to talk about, and partly so when you review afterwards, you can see.
Absolutely, thank you.
All these videos are good too. I wish math wasn't like that, and I could just tell it to you and it would go great into your brain permanently, but that's not how math works. Okay, so you've probably been told and know that you have to have common denominators when we add. So why is that? Why is it that when I have 3/4 and I'm adding, what I'm thinking in my brain is I'm thinking about fourths and I care about 3 of them. 3/4 is like 3 inches or 3 centimeters or 3 umbrellas. The fourths is like a label of what I'm talking about. So why is it that way? Let's look at this cake. A is Amy's piece. She gets half. Maybe she's older. B is Beatrice's piece. She only gets a quarter. Maybe she's younger. So if they each eat their piece of cake, how much have they eaten? I could think about this in 2 different ways. First, let's be clear. The A is 1/2 and the B is 1/4. So what I'm asking is how much is 1/2 plus 1/4? I could focus on quarters and say, let's take this picture and count the quarters. We have 1/4, 2/4, 3/4. Oops. What did I actually do there with the numbers? The 1/4 got to stay a quarter, but I changed the 1/2 so that it was 2 different quarters. I somehow made that into, oops, not with equals, but into plus. I somehow made that into 2 quarters. Or I could think about it with halves. I have my 1/2. Oh, that's too light. And then I have 1/2 of a half. And that gets much more awkward to write. I have my 1/2, and then I have 1/2 of a half. And what do I get? I get something like 1.5 halves. And this should be like disturbing and we don't like it, right? Nobody does math this way. We pick the quarters because it looks nicer. We don't want to think about like 1.5 halves. Yeah. So this one makes us happy. This one makes us sad and we won't do it. But the one that makes us happy, how did we get from the 1/2 to the 2/4? Because the 1/4 we didn't have to do anything to.
You multiply by 2 to the top and bottom.
Yeah. So going back to shape-shifting, an important part of shape-shifting was how do I take a number, 1/2, and give it the denominator I want? I can reduce or unreduce. So I unreduced by 2, and I made it 2/4. So that's our general idea. We're going to take some fractions, do some unreducing, and make them have the same denominator so we can add them. I have 3 of the 4ths. The 4th is like a label, like umbrellas or bananas. 3 is what I'm counting. Why don't we reduce instead and do a divided by 2 with the 4 to make it match the 2? Because that's the bottom picture, and that gets ugly as we just saw. So unreducing is our friend when we're adding fractions. We're going to multiply the top and bottom by the same thing. Okay, if your brain loves pictures, then maybe that helped. If not, you probably hated the past 5 minutes. Let's move on away from the pictures because they don't help everybody. No, I'm lying. One more picture. Let's add 1/2 and 1/3. I'm going to take my third. There's my third, right? And I want to add a 1/2. So I will pretend like I'm doing what I did before, and I'm going to start shading in a 1/2. Shade, 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 la, 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 la. But now I bump. I can't keep going and shade in this again. When I was multiplying and wanting a 1/2 of a third, it made sense to double shade this because 1/2 of that third would be the overlap. But now I'm trying to put more cake in the pan. I want to have a 1/2 of the cake and a third of the cake. So as I am shading, I have to sort of turn the corner and start going down this way. Now I have shaded a 1/2, and there was the third I started with. Here I'm doing a times 3 top and bottom. Here I'm doing a times 2 top and bottom. I am getting 3/6 plus 2/6 equals 5/6. My 3/6 was this 1/2. 1, 2, and then turning the corner 3. My 2/6 was this third. And I have 5 shaded in at the end. The reason I'm showing you this is in the middle of the adding, as soon as I turned the corner, I knew we were dealing with 6. During the process, the 6s were already there. I couldn't finish creating the problem until I was already thinking about 6. That's different than this other picture when we were talking about multiplying fractions. How did I know I have 12ths? Well, I count them and they're little pieces and they're 12ths. But I don't have to think about that until I'm done. I can shade my 2/3 thinking only about thirds. I can shade my 3/4 thinking only about quarters. The process doesn't need the 12, just the answer. So that's why when you're multiplying fractions, you don't need common denominators. The 12, you don't have to realize it's a 12 until you're done. But when you're adding, the fact that we're talking about 6 matters before the answer. We really need a common denominator. So again, you don't have to be able to explain that to curious people at coffee shops and cocktail parties, but you are smart. You deserve to know why we have common denominators. Okay, so how common denominators happen? There are three situations. Let's go over them. Just like we talked about different things that a percent symbol could be, and sometimes one was easier than the other, then we want to be aware of the options so we can be lazy and pick the easy one. Sometimes one denominator is a multiple of the other. So 1/12 and 1/6. If I wanted them to have a common denominator so I could add them, I don't have to do anything with the 12. I can just say 6 times 2 is 12. And to be fair, if I do something to the bottom, I do it to the top. Then we have 1/12 and 2/12. And if we were adding, we could. 1 and 2 makes 3/12. And then we can reduce and get a quarter, but I'm out of room. So let me fix that. Oops. What am I trying to do? Oh, it's not going over. I just have to erase a bunch. Sorry. Oh, no, it's not. Okay, there we go. Technical difficulties. Sometimes the denominators have no common factors. So if I have a 14th and a 15th, then 14 and 15 don't have anything in common. This is, except for one. This is 2 times 7, this is 3 times 5. Yeah, they don't share anything. And sometimes the denominators have factors in common, but it's not that one is all the way a multiple of the other. So here we have 1/12 and 1/15. The 12 is a 3 times 4. The 15 is a 3 times 5. And they both have a 3. But it's not true that 12 is 15 times something, or 15 is 12 times something. So we're not in this first situation where, yeah, they both have a 6 in common, but that's just because 6 times 2 gets me to 12. Why do we care? Because when we're on this page, we don't have to think as much. All I have to do is notice that 6 is a factor of 12, or to say it another way, 12 is a multiple of 6, and I change the 6 into 12 and I'm done. When there's no factors in common, except one, then it's always true that the best thing I can do, unfortunately, is to multiply each denominator by the other. And of course, if I do something to the bottom of a fraction, to be fair, I have to do it to the top. So what is 14 times 15? It's 210. A bigger number than I want, but add up the top. 15 of these things and 14 of these things makes 29 of these things. And I can't reduce that. So, no. So these are our favorite ones. We can get started quickly. We either change one denominator to match the other, add the tops, maybe reduce if we have to. Or we could say, I can't make one into the other, but I will just multiply each one by the other. And then again, I add the tops and I reduce if I can, and I get my answer. In either case, I don't really have to think about being clever. I'm just turning one into the other, or I'm saying multiply each by the other. There's no picking, there's no decisions I have to make. This one, on the other hand, I can be clever. Before I am clever, I could always do it like these. It's always true I could multiply each denominator by the other. I will call that my brute force method. However, the numbers get kind of big. So I like to avoid that if I can. So I will make some choices. I will be clever. I will slow down in the beginning to avoid getting big numbers on the page. So how do I do that? The process is here. There's two methods for finding what we're calling the least common multiple. And least common multiple just means exactly what it says, that I want a number that's a multiple of 12 and 15, but I want the smallest one. So some people like multiples. If you like multiples, you will just make a list. 12, 24, 36, 48, 60, 72, and so on. Those are all the multiples of 12. I can make another list for 15. 15, 30, 45, 60, 75, and so on. What's my least common multiple?
60.
60. I can tell right away that this is going to be something over 60 and something over 60. How do I know what the numerators are? I count. Times 1, 2, 3, 4, 5. So this one was actually a times 5 top and bottom. 1, 2, oops. 1, 2, 3, 4. This was actually 15 times 4. So I need a times 4 top and bottom. So who likes that way for getting the least common multiple, making a list?
I do.
I like that way.
It involves bigger numbers, but you're just kind of doing your times tables, right? It's not too bad. Some calculators, you can do something like 12 plus 12 equals 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 equals, and every time you push the equals sign, it adds 12 again. Not all calculators do that. But making lists of multiples isn't bad. Another way you can do things I'm going to, on this page, erase my 3 and 4 because I didn't wind up using those with my lists of multiples. We're doing fraction arithmetic, Joel, so maybe, maybe not. Depends on if that's something you're still good at, or like many people, need some review. Okay, what if multiples aren't my thing? What if I like factors instead? Then my trick is I'm going to make those factor trees I had erased. Before, we had only used them to notice that we are not in this situation. There was something easier than brute forcing, something quicker, something with smaller denominators than 210. Now we're going to actually use those factors, say that they both have a 3. So whenever one factor appears in both factor trees, one of them I like and I keep, and the other one, I get rid of it. Some people imagine this as you're making a layer with one on top of the other, like an Oreo cookie. So you only see one of them because the other is behind it and hiding. Then when I'm done, I multiply all these things. So 3 times 4, that 3 is gone, times a 5 is 60. So I know I am going for 60s. Oops, that should be equals. Before, we found what we were multiplying by counting how many spots we went on the list. Here, we're saying what factors were in the other tree. The blue tree didn't have a 5, so we need a times 5 here. The green tree didn't have a 4, so we need a times 4 on this side. We're making both trees match. Now this tree has a 3, a 4, and a 5. This tree has a 3, a 4, and a 5. They're both 60. If you like this way, it can be much faster than that way. But if you don't like it, then you probably don't want to practice enough to get faster at it. Okay, anyone like this way better? No, okay, it is again a way to get a least common multiple. I'm going to keep doing them both ways because you have a lot of classmates that are watching videos and not here right now, and they might like this one too. So we'll keep doing both. Okay, 1/30th and 1/42. Let's do them all 3 ways. Okay. I'm not going to pause to ask for questions right now, but you will get questions as I do this, so please interrupt me when you get questions. That brute force method, again, starts quick. I don't have to think at all, but it's going to get slow. I will get some big numbers on the screen. Notice I'm leaving some space so I can put my unreducing symbols. So the brute force method said, I'm just going to multiply each one by the other. I don't have to stop and think. If I do times 42 in this fraction at the bottom, I have to make it match. Is it okay that I'm using dots instead of X's for times?
Yeah.
Yes.
Okay,
Yes.
it's not necessary, but looks neater. Okay, so what do I get? I have 42 on the top. I have 30 on the top, and I have whatever 42 times 30 is on the bottom. So 1,260. So that's going to give me 72 over 1,260. I'm looking at these and adding up the digits. 7 and 2 is 9. 6 plus 2 plus 1 more is also 9. So 9 is going to go in top and bottom. And they're both even, so 2 is going to go in top and bottom. So I'm going to start with 18. Not what you would do, but I am cramped on the screen in a way that you're not when you're doing homework. So that gives me 4 on the top. And 70 on the bottom. Does 4 go into 70? No, because 4 goes into 80, which is a difference of 10, and 4 won't go into the difference there. So I can do it divided by 2, and that's all I can do. Now Joel is here twice. Okay, so once again, you probably did more reducing steps than just an 18 and a 2, and that's fine. You'll get to the same answer. We start quick, no choices, but then a lot of work at the end to reduce. Questions about the brute force method?
I'm good.
I'm good here.
Okay, so no one's favorite, but again, if they have no common factors, we have no choice. That's the only thing that works. This time there are common factors. I can add 130 and 142. So I'll make my list of 30. 30 times 1, 30 times 2, 90, 120, 150, 180, 210, 240. Hopefully that's enough. 42, 84, 126, 168, 210. Aha, I have a match. So the 210 is my match. So it'll be something over 210 and something over 210. What did I multiply for with the 30s? It was 1, 2, 3, 4, 5, 6, 7 times 7 top and bottom. What did I multiply it with for the 42s? 1, 2, 3, 4. It was 42 times 5. And if it's on the bottom, it needs to be on the top. Looking at our divisibility rules, then 1 plus 210, 2 plus 1 plus 0 adds up to 3. 3 goes into 3, so this will be a multiple of 3 as well as it's even, so 6 will work. So I can do divided by 6, top and bottom. And I get 2, and then 210 divided by 6 is going to give me the 35 that I had before. Okay, many students like this better than the previous way. Making that list of multiples took a lot of writing on the page, but it didn't seem to tax my brain as much as reducing this monster. Lastly, the prime factorization method, 1/30th and 1/42nd. Now, I don't have to actually go all the way down to primes. I will show you a secret. With this one, what's in common with the 30 and the 42?
2.
The 2 is even more than that,
6.
6. This is 6 times 5. This one is 6 times 7. If I broke apart the 6 into 2 and 3, I would just get more leaves to shade in yellow, but I'm going to just shade in the 6s. So again, when I have something in common, one of them, I like it and I keep it. And the other one, I get rid of. Pretend it's an Oreo cookie and I slide it behind the good one. So I multiply. I have that 6. I have that 5. That 6 is now hiding. I have a 7. So I'll multiply them all together and I get 210. What a surprise. So that's where I get my 210 in this method. And then where do I get the things to multiply on the top? Well, this factor tree had a 6, a 5, but was missing the 7. So we have to put it in. This factor tree had the 6 and the 7, but was missing the 5. So we have to put that one in. Now my factor trees match. 6, 5, 7, 6, 5, 7. Okay, so that was a 7 and a 5, and then it's the same as before. So do you have to know how to do all 3 of these? Well, you have to know the top one, because if these didn't have any common denominators, you'd do that anyway. Unavoidable. But for the other 2 methods, you can pick which your favorite is. As long as you could follow it on the board, because who knows what your next math teacher might do, then you don't have to actually be ready to make it both ways yourself on a test or something. Pick your favorite. Okay, I'm going to pause the recording. Okay, we can do a bunch more. Do you want to do more right now? Do you want to keep going with new stuff? Do you want to try the tricky one with 3 fractions?
I'm good.
I want to do at least one more thing. Should we do a subtraction? Because we've never really done that one yet.
Yeah.
Anyone mind if we do both? Can we do the 3 fraction one also?
I don't mind.
Okay, so try both of these. on your own paper. Remember when you're writing them to leave a little bit of space to the right of each fraction so you can put your unreducing stuff. And then we'll talk about how you did them. Okay, I'm resuming the recording. What do people do for the top one?
Multiply the top and bottom by 3 on 3.
Mhm. This was a case where we could change one denominator to completely become the other one. We got 9/12. Now it's minus 1/12. So how do I finish?
It'll be 8/12 and then you'll have to simplify it,
Yeah,
right?
9 minus 1 is 8. It doesn't matter whether I'm counting twelfths or cereal boxes. And then once I have the 8/12, I say, oh, drat, I'm not done. I have to reduce it.
Oh,
It's
oh, okay, he did. I'm sorry. I'm not even.
okay. Did anyone finish the bottom one?
I did.
What did you get as the common denominator?
60.
60. Did you make lists of multiples for 8, 12, and get up to 60? Did you do a factor thing? Did you do something else?
I did the list of multiples.
Okay. If you did one or the other and want to see why, then, oh, no, I am not polite enough to explain it. I will do any of them if you want, but hopefully you got to 60 one way or the other. If you multiply all 3 of them together, it gets tremendously big. Okay, so how do I get to 60? From 4, it would be times a 15. From 6, it would be a times 10. If I do it to the bottom, I have to do it to the top. And if it's a 15, it's a times 4. So 15 plus 10 minus 4. So ignoring the fact it's 60ths, if I have 15 plus 10 of something and then I take 4 away, how many are left?
21.
And what am I counting? It's not marshmallows, it is 60ths. And then I look and I say, oh, drat, I'm not done. I have to reduce. La la la, jump through the hoops. And we get 7/20ths, and then we're done. Questions about either of these?
I think you're doing it again. The number 40, I understood it better. I got stuck on that one.
Do you need me to write up more steps for 40?
I should be okay. Thank you.
So there's one more thing to talk about. We have videos, we have homework, which is the mixed number subtraction. And we could do it today because we've talked about fraction subtraction today and get it kind of all done with. Or we could say, we did a whole lot today, let's save that for next time. And after that detail, then we'll go on to order of operations and terms as our new thing to do with squishing numbers together. Do you want to do mixed numbered subtraction or save it for later? I'm thinking we should save it.
I think we should save it too.
Okay, so that's where we will start when we go on. But we won't actually go on with new stuff on Thursday. Once again, Thursday, what we will do, because I didn't do it today, is we will all look at, oops, the same version of a shape-shifting practice test to make sure we're really good at shape-shifting before we go on.
Are you gonna send that out today?
Yeah, I should just do it tonight so I don't forget. So
Okay, thank you.
obviously waiting until the morning before didn't work. Are there any of these you want to talk about now? Do you want to get a head start at looking at the homework for what we are doing that's new? We can't do all the 10 exercises for fractions and mad science yet because we've only done 2 of the 5 things. But we could see a few more examples. Or we could just do some random ones. Ooh, that one has a decimal in the fraction. Should we try that one?
We can do the randoms.
Yeah, I think we should.
We should do some more random ones. Oh, okay. The A, B, C, D we can. Is now a good time to take a 5-minute break?
Yeah.
Yes. Okay, I will pause the recording. Okay, we're back from a little break. We have everything we just did on a new copy of the Jamboard, so we could take our real Jamboard and erase it and start over. We're doing the random exercises for fraction math to make sure that we got it. So we just did one. I forgot to hit record again, but there is a 15/24 divided by 5/6, flip, cancel, get your answer. Okay, tricky, 32 over 190. Divided by 0.4 over 19. We have seen a decimal inside a fraction once before in the past 2 weeks. How did we get rid of the Icky decimal inside a fraction?
We multiplied by 10, I think.
Yes. You can think of it as a times 10 top and bottom. You can think of it as just a decimal point scoot, because that's the same thing. But we scooted this decimal point as many times as we needed to get rid of it, make it a whole number. So in this case, 1 is great. So we need a decimal point scoot on the bottom also, and we will get 32 over 190 divided by 4 over 190. Okay, I've gotten rid of that decimal point. I did this 1 scoot top, 1 scoot bottom, times 10 top, times 10 bottom, however you want to think of it. What's my next step?
You flip the 4 over 190.
Yeah. Oh, look how nice your math teacher is. The 190s cancel. 32 and 4, they cancel also. So I'm left with 8 over 1, which is 8. Not so bad. When you first looked at it, you probably thought it would be a lot harder than that. Okay, what's the least common multiple of 42 and 39? So we had two ways to do this. We could do the list of multiples. Or we could do play with factors. You don't have to know both, but you should be able to follow both on the board. So for lists of multiples, we would say 42, 84, 126, 168, 210, 252. Maybe that's enough. Let's see. 39. So it's almost 40. So 40 and 40 is going to be 80, but then it'll be 2 less, so 78. Then we'll have 120, but 3 less, so 117. These are going to take a long time. Our random number generator was not nice to us. I think I'm going to give up on the list of multiples method for now. I can go back to it later if I really want to, but I can see that these numbers are going to take a while to converge. How about playing with factors? 42 and 39. Did they have anything in common? Forty-two is 6 times 7. 2 and 3. Thirty-nine is 3 and 13. So they have a 3 in common. I will keep 1 3. And hide the other 3. So then I list out all the factors. There's a 2. There's a 3 that's not hiding. There's a 7. That 3 is hiding. And there's a 13. So what do I get? 2 times 3 times 7 times 13 is 546. So my goodness, I'm glad I didn't try listing out the multiples all the way to 546. You want to see a special trick?
Yes, please.
Okay. Special trick. Not everyone gets this, but you do. Okay, see you later, Cheryl. Watch what happens with the rest. So look at what we just did here. When we were playing with factors, we had a least common multiple that was the 546. We had a greatest common factor. We haven't talked too much about those because this is the only time you care. What was the greatest common factor of the two numbers?
3.
The 3. It was everything that we highlight. In this case, it was only a 3. One of them we kept, the other we decided to hide and get rid of. When I wanted to add fractions, which I didn't care about with this particular problem, remember how we would multiply each number by the item in the factor tree that was missing from this factor tree? The 13 for this case, or the 7 and the 2 for this case?
Yeah.
So what that is saying is I want to multiply together the 42 and the 39, but not repeat my greatest common factor. And if I put that all together, then I'm going to say that I have also the product. If I was to brute force it, 42 times 39, then here is my special trick. My least common multiple, oops, and my pen is acting up, times my greatest common factor equals the product. In this case, 546 times my 3 is 42 times 39. So all 3 of these things fit together in that equation. And we haven't officially got to equations yet, which is why I don't put this in the notes. But this means it's great if we want to work backwards. If I was asked, what is the least common multiple of 42 times 39? And the random number generator was mean to me, like this one, then I could say that 42 is 3 times 14, factoring it more if you needed to. 39. Is the 14 bothering you? Let's just do what we did before. Everyone's going to say it's 6 times 7. So then we write out our trick that our least common multiple times the greatest common factor is 42 times 39. The greatest common factor is 3. I'm not being consistent. One moment. I need to get into the equation habit. First, I should write it without anything plugged in. And then how do I get something by itself? Jumping ahead to equations, I have a times 3 stuck onto it. So the opposite is divided by 3. And then I can just say, what is 42 times 39, and then divided by 3? $546. which matches what we had before. So if you're able to do these one-step equations to get something by itself, then anytime you find the least common multiple or the greatest common factor, you can get the other one, because you can always multiply two things together. So maybe that will help you, or maybe all of this is jumping way ahead to our third topic about equations, and we're not there yet. Okay, I want to reload one that's not so terrible. Give the much better, 50 and 60. Now the people that want some lists of multiples can have their day. If you are a play with factors person, then do it that way while I'm doing the list of multiples way. Okay, this won't take forever. So 50, 100, 150, 200, 250, 300, 350, and so on. 60, 120, 180, 240, 300. Aha, I have a match. 300 works for both. If I'm playing with factors, 50 is 10 times 5. 60 is 10 times 6. Maybe I broke up 10 into 2 and 5. Doesn't really matter. I have a 2 in common. I will like one of them and hide the other one. I have a 5 in common. I will like one of them and hide the other. I have another 5 on this tree, but it has no match on the other tree. So it just sticks around like an unhighlighted number. And the 6, I could break apart into a 2, but there's no 2 over here to match with. So whether or not I break it apart doesn't matter. This is the first example where we've had 2 different things highlight, but that's okay. It's still true that I'm just going to list out everything now. There's a 2, there's a 5, there's another 5, this 2 is hiding, this 5 is hiding, there's a 6, which I could write as a 2 and a 3, or I could leave it as a 6, doesn't matter. Multiply everything together, and I will also get 300. Or if we're doing the special trick, for those that have a little more algebra, so our least common multiple times what's the greatest common factor? It was that 10. And what's 50 times 60? 6 times 5 is 30 with 2 more zeros. Divide by 10 to get the LCM by itself. And 3,000 divided by 10 is the 300. So lots of ways to do the same thing. Okay, we also had find the sum of these things. So I leave some space for my unreducing. And this is as hard as you would be asked to do something on a test. If there's some thing that might be a time limit someday, even if it's not in a remote term, then no one's going to ask you to do harder than this. So what is my common denominator going to be?
12.
12. If you can't just look at it and get it, then do either of our things. Make a list, and the 4 will go 4, 8, 12. The 6 will go 6, 12, or break things apart. This time the list was the quicker way. Okay, how did we get to 12 times 3 times 2? If it happens on the bottom, we have to do it on the top. So I have 3 of something and 2 of something and 8 of something. 8, 9, 10 plus 3 more is 13 twelfths. And if you want to write it 1 and 1/12, you can, but this is good enough for me. Should we reload and try more of these?
Sure.
Okay, I've reloaded. There's new ones. Which one do you want to do? Not ERF. Those are future topics.
Can we try B?
B? Sure. So this one again looks much scarier than it is because I'm a nice person and the numbers will work out nicely. You just have to remember 2 different how to do things. Where did we start when we did a similar one before?
There's a bowl out for you.
I believe we multiplied by 10 for the 0.5.
Yeah, we did a times 10 and a times 10. So then we got okay, then what?
Flip the second one.
Yep, flip the second one, change to multiplying. And how friendly this is, those cancel out. You don't have to write the ones, I'm just doing that. 40 and 5 cancels, 5 divided by 5 is 1, 40 divided by 5 is 8, 8 times 1 is 8, 1 times 1 is 1, and we have 8. I think it coincidentally was 8 last time. Doesn't always equal 8. Yeah, it was 8 last time. Coincidence, not always. Okay. You want to stare at it more? Am I rushing? I should talk about this. You can use your calculator's fraction key to find an answer. So let's say that there's one that has a big reducing. So let's go back in our notes from earlier. Where was that big monster reducing? Here we go. 72 over 1260. So if you have a calculator key that looks like A, B over C, or maybe it just looks like A over B, something like that, then usually your calculator would let you just enter 72, do that key, whatever it looks like, where the fraction bar happens, and then the other number, and equals, and then one of two things will happen. Sometimes your calculator is the kind of calculator that will give you the reduced number, and you'll see on your screen right away 2 over 35. Your calculator will reduce fractions for you. Other times, your calculator is the kind of calculator that wants to make a decimal. And then you would see on your screen at this point, 0.057142857, blah, blah, right? Whichever case it is, if you hit the key again, then it should go back and forth between them. Or maybe you have yet another button on your calculator that looks like the word change with arrows above and below. Some of the newer calculators have that button, in which case that is the button that changes between fraction and decimal format for you. So play around with it a little. If you can't get it to work, this is a great thing to briefly meet with me in Zoom about, not during the middle of class lecture, because not everyone has your calculator. Or if you go to the Zoom lane help, then they are calculator experts even more than I am, although so far I'm pretty good. But you should be able to use either this button or a combination of this button and this button to both reduce a fraction and go back and forth between fraction and decimal. You will want to know how to do it by hand, because once you start putting X's and Y's in, which certainly happens on the GED, then the calculator can't help you anymore. But to check your work at the end, it's nice to be able to just be able to stick it in the calculator real quick. Is there anyone that can get it to work and wants to say so, or isn't working for them and they want me to try and help them real quick?
Mine's working.
I got it to work.
Okay. That doesn't mean slack off and don't learn how to do this, but it does mean that you can check your work. And it means I can't write a K. Very nice. Okay. Should we do one more? I can reload again. Least common multiple of 18 and 16. Would that be a good one?
Yeah.
Okay, which one should we do first? List of multiples, play with factors, special trick.
List of multiples.
Also, okay, 18 and 18 is 36. Another 18 is going to give me 54. Another 18 is going to give me 60, 72. Another 18 is going to give me 70, 80, 90. Somebody check my mental math because it's getting late. Maybe that's enough. 16, 16 and 16 is 32, 48, 50, 64, 60, 70, 80. Nope, we're not copying yet. 96, 112, 90, 108, 8 and 8 is 16, 126. We're getting close, but not there. So I'm gonna come down to here. 144, 130, aha, here we are. I'm just gonna move my special trick stuff. What was this one? One 28, 144. This was 126, 144. Yep. So yay, 144 is the answer. Playing with factors, 18, 16. What do they have in common?
2.
2. 2 times 9, 2 times 8. So I will take one of the 2's and say I like it, and the other 2 and say that one I have to hide. And then I list them all out. We have a 2, we have a 9, that one is hiding. We have an 8, 2 times 9 times 8 is 144. Or we could take our special trick. If you like that kind of algebra. So our LCM times the greatest common factor was 2 is 18 times 16 is my product. So LCM times 2 is 288. And then something is times 2. So to get it by itself, I divided by 2. And my LCM is 144. So 3 ways to do this. Pick whichever you like best. Okay, it's past 8:20. Any last things before we stop? I'll stop the recording.